Nyquist sampling. My name is Juan Guinosar, and I'll be chairing the first session this morning. The first speaker will be the Dean, Professor Adam Schwartz, who would welcome us.
Good morning. So I'm not the first speaker. I'm just here to say some niceties. So welcome to the Electrical Engineering Department and to the Technion, and welcome to the workshop. I think the subject of sub-Nyquist sampling is a reflection on our department, in that what we try to do is science with theory that are deep and fundamental, driven by applications, and with a system view, and with the hope that we'll have some impact on technology. So this is what this workshop is all about. So enjoy the workshop, enjoy the lectures, enjoy the interactions and the networking, and have a good day.
This is the first example of sub-Nyquist sampling. He was assigned 10 minutes. Oh, okay. Okay, so the next speaker is Professor Yonina Eldar, here from Electrical Engineering Department. She will first introduce the whole project and then go into the talk about defining Nyquist and analog to digital conversion. Yonina, please.
Good morning, everyone. Everyone hears me? Okay, so good morning, everyone, and welcome to the sampling workshop. It's really nice to see so many people here so early in the morning. I hope we'll be able to keep you awake throughout the day. So really what this workshop is marking is the launching of a new activity in the department, a new lab in the department, that is a joint effort of my research group and the HighSpeed Digital Systems Lab. So what I want to do before I start with the technical talks is give a little bit of an overview of what this workshop is about and the different groups that are involved in this project. So let me begin by my research group. So the people you see on the slide are all students in my current group, and they're all here in the audience. So feel free to look on the slide and then recognize them and bug them with questions throughout the day. I really feel very fortunate to be working with such a great team of students. So all of the work you're going to be seeing here today, of course, would not be possible without the research group. I'd also like to mention many of my former students who worked specifically on the topics we're going to be seeing today. So you see them here in the slide. They've flown away, left the nest, but of course their work stays with us, and you'll see a lot of it today. I'd also like to mention a few of the other labs in the department with which we did some of our original activities. And in particular, we have two very strong labs in the areas of signal and image processing, CPEL and VISEL, where we did some of our algorithm development in the early days when we were working on these topics. So as I said, our major effort has been with the HighSpeed Digital Systems Lab. And in fact, all of the demos and prototypes that you're going to see here today were developed within the lab with the very dedicated staff of the lab. So again, they're all here today, and you'll see some of them throughout the day. And really, without the hard work of this team, we wouldn't be able to implement and realize all of the hardware prototypes you're going to see here today. So let me just say a few words about the HighSpeed Digital Systems Lab. So this is a very big lab in the department. This lab focuses on different system design and architecture design in various areas. So on the slide, you see only a sample of some of the areas that the lab is involved in. And in the lab, what is done in the lab is both, of course, research and also a very, very important educational aspect to the lab. So there's many, many projects in the lab. In fact, there's about 500 students yearly that run different experiments in the lab, so there's a large volume of students, and about 50 projects that are more research-oriented projects. And we've been very fortunate to conduct a lot of projects within the lab, and a lot of the system development you'll see here today was done through projects of undergrad and grad students in the lab. And in fact, we don't have time throughout the workshop today to go through all of the different activities. So those of you interested, you could see posters throughout the breaks. There's posters outside that give more detail both on the research projects and on the different undergrad projects that were conducted within the lab. So the nice thing about the HighSpeed Digital Systems Lab from our perspective is that they're really experts on hardware design and high-speed design, which are both very, very important for the complex systems that we want to build. So here we connect very naturally to the lab and to the lab activities. Of course, beyond our specific research group, we've been very fortunate to have strong collaborations with other groups within the Technion and out of the Technion. In particular, I'd like to mention a very strong collaboration we have going over the past few years with the groups of Professor Moti Segev and Oren Cohen from the physics department. And Moti is here with us today, and he'll be talking after me about some of these activities. And here are also the students from these groups that are working on these activities, and some of them are here as well. So again, you could bug them throughout the workshop. We've also had collaborations with different groups throughout the world, and really the reason why we have so many collaborations in this area is because besides developing the essential ideas and the prototypes that we're doing all here at the Technion, we're also very interested in developing various applications. And here we really try to connect to the experts in the world in these areas so that we could really treat the applications in a very fundamental way. Besides our academic collaborations, we have many industrial partners. So some of you are sitting here in the audience, and we'll hear some more about these collaborations with industry throughout the day. In particular, I want to mention our collaboration with NI and James Kimmery, who's here with us today and who flew in special to be here for the workshop. So we're very grateful for that opportunity. Okay, so let me talk about a little bit what you're going to hear today throughout the day. So here's the agenda. I think all of you have a copy, or you could get a copy outside. But really, the workshop is broken into 3 parts. So the first part, which is the part we're at right now, is an overview part. So right now, I'm giving an overview of the workshop. I'll then give an overview of what this sub-Nyquist sampling actually means. I'm not going to go too much into technical detail. It will be kind of a high-level overview. Then Professor Moti Segev will give an overview of our activities in the area of sub-wavelength imaging. And again, this is done together with the groups at the physics department. In the second part of the workshop, we'll go into greater detail in each one of the applications that I'm going to be talking about in the introduction. So we'll hear talks from 3 of the students in my group who will talk about some specific applications. And we'll end that part with a live demonstration. So that's all the equipment that you see here on the stage. We'll end with a live demonstration done by the HighSpeed Digital Systems Lab. And in particular, Rolf will be giving the demonstration together with Idan. In the last part of the workshop, we'll be focusing on collaborations with industry. So we're very happy and fortunate to have some of our industry partners here today. And they'll be talking about various areas where sub-Nyquist sampling could be relevant in industry. Okay, so that's what the agenda. Now let me just take 2 minutes before we kind of go into the details and say, you know, what this sampling is all about and basically why we have this need for this new activity and this new lab. So really kind of in 2 words, sampling, if any of you wondered where the name comes from, so sampling comes from a combination of compression and sampling. So the idea is really to try to sample in such a way that we compress while we sample. We only take the actual information that is needed. And that's where the name comes from. X also symbolizes compression in general. So this is really coming to symbolize that we try and sample in a way that we only take the information that we need. And of course, there's many advantages if we can do that. It's not always possible, but when we can do that, there's many advantages we could get. So of course, this leads to faster systems. We reduce the sampling rate. It leads to smaller systems, lower cost, lower power. And some other aspects that are important to notice is that actually it reduces the DSP as well. So that's very important. We're often focused on the DSP and not so much on the analog side. And of course, if we could sample with fewer samples, then we could do faster processing as well. Another very important factor is that there's some applications where technology today just simply does not allow to process very wideband signals. And this is really important because if we could do it properly, the way we're going to show today in the workshop, then at least in some application areas, we could really break technology limits. So it's not only necessarily a cheaper way of doing things, but maybe the ability to do things that previously we weren't able to do. So this is really focusing on the aspects of sampling, but beyond sampling rate, there's other benefits that we could get as well. So once we know how to exploit the knowledge of the signal in order to reduce sampling rate, we could get a variety of other benefits, such as increasing resolution, and Moti will talk much more about that after me. Dynamic range, we can improve dynamic range. We could be more robust to noise by properly exploiting the data. And finally, the interesting thing is that because we started looking at sub-Nyquist sampling, we had to be creative, right? We had to think of different ways of building sampling systems. And this actually led and is leading now to some activity in the area of standard systems. So even when we're not trying to reduce rate, but it leads to different ways of thinking of designing A to D converters. So there's some nice aspects here that relate to kind of standard ADCs as well. Okay, so as I said, the focus here is really on the establishment of the lab. And I want to say a little bit about why we feel that that's so important, specifically in this area. So for those of you familiar with the research on sampling theory, there's been a lot of work over the years on research in sampling theory. There's many, many important people who worked on these problems and a lot of very, very interesting literature. However, if you look in industry and things that are done on kind of an industrial scale, you'll see that almost everything still adheres to the kind of standard Shannon-Nyquist paradigm. Okay, so sampling at twice the highest frequency of the signal. And when we started working on this project, actually this is something that we noticed a lot. So there's a lot of literature on different areas, not necessarily having to do with sub-Nyquist sampling, but just in general on different sampling architectures, but very little industrial impact. So in the industry, still people sample at the Shannon-Nyquist rate. And one of the things that we were concerned with when we started these ideas is that at the beginning we were very much focused on the theory, right? Because we were trying to kind of break limits that exist today, develop new research paradigms, develop new mathematical tools. But after we were able to do that and to show that at least in principle this is possible, the question was how do we change this disconnect between what we're doing in research and what actually happens in industry? And this is really what we believe is the importance of the lab. So really, we would like in the future, and we think that it's possible, to really have an impact on technology, to make these ideas really find their way into industry. And in order to do that, we feel that having a lab is extremely important. So really, we believe that the key to having impact in industry in these areas is, of course, to continue to develop new theories. So we always want to try and be at the forefront of academic research. So that's definitely one of the most important components. But also, it's very important to us to try and hand in hand with developing the theory to actually realize prototypes, to understand what it takes to go from the theory to the prototypes, what we have to change in the theory in order to be able to make it into practice. So realizing these prototypes in the lab is very, very important, and this is where our combination with the HighSpeed Digital Lab is extremely important. And of course, industry involvement. So we want to make sure that at the end we work on problems that are relevant. We want to be able to try and integrate the needs of the industry. And for that, of course, we need the collaboration of industry so that we get a better understanding of where there's a need and where we can make a difference. So our vision, okay, so this is kind of the last slide, but I think it's very important of, where we hope to go in the future. Where's our vision? So we really hope to establish a center of information for the topic of smart ADCs. And of course, this center will include various components, so we'll continue, hopefully, with the help of the great students that we have here at the Technion, we'll continue to develop research and understand fundamental limits, develop mathematical aspects and digital algorithms. We also, at the same time, want to be able to have an impact on technology. We want to continue to develop our prototypes. We want to continue to do research in prototype development. There's a lot of research to do there as well. And we want to work our way into applications. So again, applications has an academic side and also a very strong component of industry. So this is really where we hope to have the involvement of industry and together to have a center that we really hope could really make a difference and move to a paradigm shift in the way ADCs are designed. Okay, so that's our vision. And with that, let me move on to back to what we see here on the stage and to thanks for all the people who really helped put this workshop together. So there's a lot of work involved, apparently, in getting a workshop up and running. So first, I'd like to thank all my research students who are here, of course, also for the work, but also for helping with various aspects of the research. And of course, the extremely dedicated staff at the HighSpeed Digital Systems Lab. So I think no one in that lab really slept in the past 2 weeks. So really, really a deep thanks to all the people in the lab, not only for what we see here today, but for our ongoing collaboration. There's many people in the department who helped with setting things up. So I'd like to thank Yoram Shabtai, Yanki Yavor, Yoram Olchen, Yafa Levi, Sasha Asimov. And there's 3 people who in particular I want to thank. So I know I'm going to embarrass you, but I'm going to call you to the stage. So I apologize, but I think it's really important that people know who's behind all the work that you see here today. So Susie, Ina, and Ellie. Don't be embarrassed. Please come to the stage. So these are the 3 people who really took care of everything you see here today, starting from the small details to the larger details. And I'd really like to thank each one of you individually. So, thank you very, very much. I'm sure that it's not always easy. I don't even count the amount of emails I sent him a minute. So thank you very, very much, Ellie, for all of the work here, for all of the whole collaboration with the lab started through Ellie. So thank you very, very much, and I look forward to many years of continuing collaboration.